Hello everyone, nice to see you again. I'm Freeze. In this tutorial, in this series of tutorial, I will explain some basic operations of Codesys and how to program in Codesys and then how to configure the filters with a couple protocols and so on. As you know, Codesys is a very famous platform by now, and Cookies is very flexible. It can let you to install in different OS. For example, you can run Cookies even in your Windows and some Linux computer, or even on just in your Raspberry Pi. And also, there's some manufacturer who customize their hardware and then to provide their hardware that can install the Cookies. And in this case, in my series of video, I will use a Italian PLC manufacturer called PixSys. It is a very professional in plant applications, very good for the environment, and has a very high temperature or something. And very thanks to them, they brought a startup kit for me to play with that. So I'll use this demo kit to make some tutorial courses and then to share what I know. Okay, so let's start. And if you first thing that if you are would like to use run the courses in your computer, then you can just go to courses website to download the latest version of courses and then install to your computer. That's work. But in this case, you're using some manufacturer customized hardware, then you need to download some package from their website, their own website. So if you use Raspberry Pi before, I mean you have a Raspberry Pi that installed the Cookies before, then you need to go to Cookies website to download the package and then install into your Cookies IDE. So in this case, it should be same because it should be same. PixSys also provide a package for you to install in your computer inside your Cookies. And let me show you. So here, and go to here is the PixSys website, and you can just go to login. You can log in it and just search PixSys SYS PL700 PLC, and then you can go to the download page. You can jump this web page and then just register a member. Then you can it's free here and you can download so many package inside. And in my case, what I need is this one, Codesys control for PL700 package. Then you need to after downloading, you can install it inside your computer. Then you can configure PL700 as your for your Codesys device. Just in case, for example, this time you're using PL700, next time you use Raspberry Pi, or next time use some Codesys PLC that's made by other manufacturer, you just need to do the same things, go to their web page, and then download their package, and then install into your Codesys or into your PC. That's right. And here you can see that here's my CPU, and in this I have a analog in-output module. Here is a digital in-output module and an analog in-output module. And this is CPU from this is a how to say that this CPU they are using CANOPEN to communicate with these two modules. So this is one is CAN master, it's a slave, and this slave. Then for the CANOPEN communication, if you use CANOPEN communication before that, it's very convenient that you have a EDS file that you can download from the manufacturer's website. PAX is also same. You can go to here, that is the M2 MCM2600 and 260XPLE find something EDS file, just download it and then install into your Codesys. Let's go to tubes and then device vulnerability and then install. This shows your EDS file in this download and then install inside your computer. Okay, so on this one, I think you prepare all the things you need. We can start now. So go to File and New okay, so there's one more thing I would like to mention is here I'm using the latest versions of the Codesys as 3.5 SP18 patch 4. But sometime maybe it's better to use some older Codesys version to match your hardware to maybe have some even some reasons. So you can just go to the Codesys website and where's the Codesys website? And yes, you can download the Codesys development system with free and then click the version. So here you can now the latest version. But if you want to use the some older version, for example, 5.17, 5.16, just go to the version tab. Then you can find all the old version of the Codesys. I hope it's old version. You find the Codesys, the version, all the versions of Codesys. Then you can choose what version you want and download and install your computer. And don't worry, you can install a couple versions of Codesys in one workstation. Okay, for example, here you can see my computer. I install S16, 17, and 18. Okay, but it's not important. Okay, so go back to our Codesys IDE. I hope you open the Codesys development system and go to File, New Project, and enter your project name. For example, my demo project is one. Okay, then here is the standard project screen pop-up. Then here is device. If you're using Windows as your Codesys runtime system, then I maybe you choose Codesys Win3 or Win VVX64. It depends on your operation system is 32-bit or 64-bit. Or if you're using Raspberry Pi, then maybe you use Raspberry Pi MCSL. And in my case, because I installed the package that download from the PixSys website, so now I can choose PL700 VV5180 as my device target. So this P7 VL700 is this PLC. Just press OK. Then now it's creating the project. Okay, so as this time I can show you my comparations. And here's my CPU. There's two modules before, right? Then I have a bottom. The bottom is connecting the DI channel. And here is my analog simulator. You can generate from 4 to 20 milliampere or and 0 to 10 voltage. And here is a tester used to let me to measure the current because it's not easy to measure current, and this module can only output 0 from 0 to 20 milliampere or 4 to 20 milliampere. Okay, so here my project is great. I can start to configure my network to add these two modules inside my project. As I mentioned before, this module is using CANOPEN to communicate with the master. In this side, in this case, is PL700. So what can we do? We can just add a CANOPEN network in my project. Click the device, right click, I think it's add device, and then choose view bus, CAN bus, and CAN bus, and add the device. And I think it's better to use the latest version, the newest version that you can configure. It should be better than use some old version. I don't know what kind of bugs is inside. I think Codesys they're also fixing the bug by release the latest versions. Okay, now a CAN bus is set, and I just press OK. And network just now to be 0, and for the baud rate we'll choose 1000. If the reference band is the manual, you know that they're using 1000 kilobytes per second to communicate to each slave. Okay, so the master CAN bus is configured, so now we can add a CANOPEN master. Let's right click it and add device again. and then choose CANOPEN Manager. CANOPEN Manager. So it means this CAN bus will be a CAN master device. Now a CAN Manager is config. Now we see and just open it. No idea this one's 127. No need to care this stuff too much. And now we can add these two small module in our project. Just go to right click and then insert device. Oh, sorry, it's add device. Add device. And here you can see all the all the CANOPEN slave device that are installed in your Codesys development system. So if you follow the instructions I mentioned before, that you will see slow down, you see some module will come from PixSys. So in this case, our first module is PLE 500 So we just want to choose it and edit, double click to edit. And then the second one is PLE 500 Just do the same things, edit. Okay, done. Now we configure our CANOPEN master that with to slave in here. Now we can try to download our project to the CPU to check the canvas is working or not. Login, no patch. Okay, no patch. We need to configure a patch that scan network and then execute a connection from your OS, from your PC to the PLC first. Just click the device and scan network. If you're connecting and no problem, you can select the PL700 in here, or just your Windows runtime. It's okay. And right second. And then if your connection is okay, you can see the target type, the target version, and the render. Okay, just log in again. Yes. And just wait a second. It needs some time to download the project from your OS to the CPU. And let's open the here. You can see now it's flashing red, flashing green. It means the module is starting up. Okay, now download is finished. Just run it. Great. Now you see all the icon is in green. It means your canvas and your CANOPEN master and also your CAN slave are running normal without any problem. Good. Now our first step is done. Now I'll show you how to configure each module. If you use I think if you use for example analog input, analog output, there's so many parameters you need to set. You need to set each channel, the input range, output range, and what's the limit, or actually it is you can receive a voltage or a current, and there's so many stuff you need to check, you need to set up. So if you I show you how to configure it in using CAN bus in a CAN bus system. Let's click the PLE 500 If using CANOPEN before, there's a two types of object. One type main object in main the two main types of object inside. The first one is PDOS, is process data object. The second one is SDOS, is service data objects. For the PDO, you can imagine PDOS is some data you need to control. It's directly to control the system. I mean, you can just imagine it as I/O data. Therefore, the service for the SDOS is a service data, just as you mean, it is something just for service, or say the one time to configure your module, or to change the parameters. Something is not for the main control. So let me check the PDOS is the main parameters we need to configure in here. We need to set which of data that we need to receive, which of data we don't need to use it. Okay, so in here is a receive directions from my master to slave, from master to slave, and here is from slave to master. So slave master is from here to here. And here you see there's a digital output block 1, 2, and digital input run block 1, 2. So what's that mean? It's very easy. So block 1 is mean here, block 2 is mean here. They have in this module they have 60 digital in output. You can configure it because it's configurable. And the first one here is 60 is you have channel 1 channel. I'll say that you have 8 bit is the channel 1, total channel 1, and here is channel 2. It also is 8 bit data. So first one I'll use this channel as the digital input because I have a bottom here, right? And here I'll configure as the output. So what should I do? The first thing, I just need to delete this second one of digital input block. Just click delete, okay. And then here, the same thing, I no need the digital output block of my first channel. Do the same thing, delete it. Okay, the first one is done. And then now we need to configure the analog input channel and output channel. And here, I think because the image is very small, you cannot see it. And here they have the two input channel, analog input channel, and here's two output analog output channel. Then what we need to do is here to just right click and add mappings, and then go to the 2 by special input area, and then just add the this is the first channel. Just do the same thing to the other channel. Okay, so now configure the input data. Now it's the same with the output data. Just add channel, add mapping, and then to add the first channel and the second channel. Okay, now we configure all the input data in here. The next thing we need to do is to configure the parameters of each channel, each points. So we go to the SDOS. We can add the SDOS to set our parameters of the modules. But how do you know what parameter is there? First thing, you can just press SDOs. Then they have some names. You can know there's some meaning of these parameters. But maybe you not know how which value is for which setting. So you need to check the menu. I think here is the menu of this module. Then they go to the Part 6. There's a conversions parameter tables. They have a parameter 1, 2, 3, 4, 5, 6, 7, 8. I think go until 36. So in here, I will just open the 60 the shop 3000 parameter index and go inside. For example, when I just randomly check a parameter, for example, the filter function of the analog input channel 1, it is 0F, right? So let's go back to menu, just check 0F. Indexable COF 0F is equal to 15, so it's AI doc 0 input filter. So in here, same filter AI 1. So everything's being easy. I'll check config my uh, I config my parameter first. When I need to figure out the output type AO1 and AO2. So here's parameter 17 and 18. 17, 18. So for the 17, 18, the value is 0, and you can pick out 1 or 2. And for the first channel, I configure it as 1, so the analog output is not from 4 to 20 milliampere anymore at default. It will change to from 0 to 20 milliampere. Just click it, and then value input to 1. Okay, just click a comment here, 0 to 20 milliampere. Then same thing, 30,000. Although the default value is configured inside, I would like to configure again to make sure our setting is exactly will be sent to our module with SDO. Okay. So the next thing I would like to configure the upper value, upper limit is I think is parameter 21. Yeah. So what's this one? Is mean when our what's the value when the output should when we would like to output the maximum. For example, in our case, it's 20 milliampere. What is that value? The first 1000, I think it's not easy to use. I would like to make it more scalable. I will choose it. This value is 60 hex as 7999. Okay, and then finally, I would like to configure the input type. So go to 6 sharp 3000. And then say sensor type, we have AI1, AI2 because I have two channel of analog input. So we'll check the menu, go slow up. And then as you see, you have three types of sensor that we can uh, input to our channel. The first one is voltage, and the second one and the third one is current. In our case, I'll use voltage. It's easy to handle, so I just keep in the 0. But just the same thing, edit, then to make sure I'll set my channel as a exactly setting. Just go to here. Okay, so done. We config all our parameters. Then finally, what we need to do, we need to config the mappings. If you open the CANOPEN IO mappings, you'll see some data in here. You can map all the data or this process style to our user program. I will show you how to do it. It's very easy. So in this case, I will not create so complex program. I will just define some variables into the main voice and main program here, and then directly link to our modules. So when you check it, let's go to, keep it this one, and then open here, and then just do it like this. Then we can split the windows and see what I do very clearly. So we first thing we need to have a digital output and digital input, right? So here, this one, right? So what I do, I'll just put di output do channel do mm, do channel and usind and size short integer di channel just do the same thing. Okay, so and then we have two analog input and two analog output, right? So I just AO channel and use array of int, and then it's the same thing is AI channel array 01 of int. And finally, I would like to use some buffer, for example, switch on. Let's say boot type. Output test output so the boot type, then buffers, okay, and then set point. That's the same as array. Okay, done. And then we can map this data. I don't know why some error. Okay, have some typing error here. Oops, not this one. Okay, I think now should be okay, but don't know here same. Just copy these characters, go here, paste it. It should work. Okay, no error. And then we map it here. Just click the variables, and then here's a button. Click it. Applications, PLC. Then you see the all the variables we defined in before. So okay, so it's the digital output, right? DO channel. And then doing the same as input, DI channel. Okay. And then I have the analog output, right? Just the same thing. Go to AO channel, but Codesys didn't only can do like this, so need to assign which element need one, right? 0. Just copy it, change it to 1, and then same thing to the analog input channel, AI channel 0 and 1, 0 and 1. Done. Now we figure out all the parameters from the PDOs and SDOs, and we finish the mapping. Now we can program it. Just do some simple program. For example, I would like to check the switch on or not, right? Switch on is equal to DI channel, first channel, and then I would like to turn on some data, some output, digital output. So DO channel equal to test output. Okay, maybe I can turn on one more. Great. Okay, and then we just buffers is equal to AI channel, and the AO channel is equal to support. Okay, good. Program is done. Now we can download up our program, our whole project to CPU. Let's log in it. Yes. And then wait a second. You can read the CPU here. Need some time. Okay, done. And then play it. Okay, now the mode is on running. We can check the bottom first. Okay, open our camera again. Let's put it here. Oops. Oops. This one. This one. Yes. And just take this one to be easy to see. When there's a bottom, I plus it. You see it being true. And you see the value is changed to 2. And because we can use this method to access the bit, to use a bit access of in a 6-bit 16-bit data or 32-bit data. So 0.1 is mean the second bit. The first bit will be 0.0 dot 0. So you see when I press this button, it will be developing to 2. So it's mean 1, 2, 4, 8, 16. The second bit will be turned on. And then now we can turn on the output. Just click it, double click it, and right click, write all value. Done. And then go back to here. You can see the channel 0 and channel 3 is turned on. And then we can turn it back to off. Okay, now you see that all the lamp is not turned on. It means the output is shut down. And then first thing we can check the analog channel. For example, we open the buffer. And as you saw, I showed before, here is a analog generator, a simulation simulator. You can generate a 0 to 10 voltage, and also 4 to 20 milliampere. What I need to do, I just want to rotate this rotating switch. Then, for example, now you see the voltage around 2.9, right? It is just opposite here. So yes, the rate is 2.88. It means 2.88 something. Then just go to so 5.3 is a 527 something. Just okay. You see, okay, so even the analog input is okay. Then finally we can quick check the output also. Just open the output here. And because it's not easy to measure the current, you see here is my first output, the first channel of my analog output. I will connect it to a jumper, and then here is the measure, or to go back to the tester. And then when after I turn on, I write some value to analog output, I can just measure the ground to check how many milliampere that is outputting. The first thing we need to turn on our tester first. Okay, change to 20 milliampere. And then we can write some value here. For example, I write 4000. It means so as we check the value, it should be around 10 milliampere. Let's check it. Great, it's around 10 milliampere. You see here it's 9.98. So and then we can change the value to around, for example, 7999, and then just write it. Okay, this one, right? It should it should be 1890 milliampere. Okay, so for example, we set the value as maximum. Okay, just open back here. Okay, use this one. It's around 20 milliampere. So it's done. Maybe you said why I need to use this. This is just for this practice system only, right? I would like to tell you that the answer is not true because um, although this module is only for the CPU, but the configurations of CANOPEN is same. For example, if you use Vago before, Vago they have their own Codesys, their own engineered tubes called equipped with a Codesys engine integrate inside. The CANOPEN parameter setting is exactly the same as what I do in here. You need to configure the PTO, you need to configure the SDO in the same, and even the screen is more than 90% same. It should, so it's just better to, if you know this one, you know how to configure the CANOPEN, you know how to configure the PTO, the SDO, then you can just use Art CPU as same. You don't need to take care too much. Okay, so I think I should end in this video. It's maybe a bit long, and maybe in the future I'll use this small gray PLC sh uh, to make small tutorial. And if you like my video, please like it and subscribe and share to other friends. Okay, so see you next time. Bye bye.